Hello and welcome to this special Nomira class. Today we want to look at important formulas in solving quantitative analysis. Let us begin by reintroducing quantitative analysis. I have discussed this in our previous video, so you need to go back to see how we have discussed it. I also conducted an experiment under quantitative analysis, which is acid-base titration. Okay, let us briefly look at what quantitative analysis is about. Quantitative analysis is that analysis that determines the amount of an element or compound in a substance. So it talks about amount. Okay, so quantitative analysis is classified into two. We have the volumetric analysis and the gravimetric analysis. From the root word volume, this measures by volume. This is just measurement by volume. Why this measures mass? Okay, it is very important to note that we use this in chemistry, in secondary school chemistry. This is less accurate than gravimetric analysis. It is in volumetric analysis that we conduct titration, acid-base titration to be specific. So let us go in details by listing out different formulas that will help us or enable us to solve questions involving quantitative analysis. The first one is what we call the dilution formula. Dilution formula is CAVA over CBVB equal to NA over NB, where Ca is the concentration of acid, Va is the volume of acid, Na is the number of mole of acid, Cb is concentration of base, Vb is the volume of base, and finally Nb is the number of mole of base. It is very important to know that the concentration of acid is usually in a mole per dm cube. However, this is not limited to concentration. Concentration are in two types. We have types of concentration. But before then, what do you understand by concentration? Concentration is the amount of solute in 1 dm cube of the solution. It means that if you are using number of mole, it means that it is the number of mole of a substance in 1 dm cube of that solution. This will make sense to say that the unit is in mole per dm cube, number of mole in 1 dm cube. Then concentration generally is in two types. We have the molar concentration. This is the one that we just mentioned here, the unit there, the molar concentration, or what we call the molarity. Unit of molarity is mole per dm cube, or capital M. So the other type of concentration is what we call mass concentration. Mass concentration unit is what? Gram per what? dm cube. This is the mass, the mass of a substance in 1 dm cube of that substance or solution. Okay, so this is it. Then the VA is the volume of acid. Usually in quantitative analysis, after the titration, we do the average volume of acid used, which we usually call our end point. That end point is what becomes our VA. It is gotten by doing the average titer or the average volume of acids used. So the average volume of acid automatically becomes our what? VA. So Na and Nb are gotten from a balanced chemical equation. I'll teach you how to balance chemical equation. Okay, then Cb is the concentration of the base, Vb is the volume of the base. This is the exact volume of the pipette that was used. Remember, we usually have two capacity pipettes. We have the 20 ml capacity pipette. If you are using the 20 ml capacity pipette, it means that your Vb is 20 cm cube. If you are using the 25 ml capacity pipette, it means that your Vb is 25 cm cube. Okay? In other words, the volume of your pipette automatically becomes your Vb. So let us delve into how we would discover or find out our Na and Nb, which I told you that you get it from what? A balanced chemical equation. We are discussing quantitative analysis and we're going to limit ourselves to neutralization reaction. What is neutralization reaction? Neutralization reaction is the reaction between acid and base to form what? Salt and water only. That word only should appear there because in neutralization reaction, only salt and water is produced. Any other thing that is produced alongside salt and water, it means that that is not a neutralization reaction. So for us to get Na, our Na is obtained from the number of mole that you see here. Any number that is written in front of the acid becomes your Na. Any number that is written in front of the base becomes your what? Nb, right? So Nb is going to be whatever that is written here. So that is that. So let us give different examples of how to balance chemical what? Equation, so that it will enable us to what? Apply this formula very efficiently. So let's see balanced equation between, let's say, sulfuric acid plus sodium hydroxide, which will give you what? Sodium sulfate and water. Okay, this is H2O. In balancing chemical equation, how to balance chemical equation. In balancing chemical equation, we are only allowed to put numbers in front of the compound. They serve as the number of mole. Okay, we are not allowed to add on the subscript that is under the elements. Okay, so you look at the number of what? Individual elements in the reactant side. This is called what? The reactant side of the what? Chemical equation. Then make sure that the total number of any of the elements you are considering is equal to the total number of that same element in the product side. This is called the product side of a chemical equation. Okay, so let us begin with judging hydrogen. Hydrogen here is what? 2. plus there is another hydrogen in this compound. So we have 2 plus 1 hydrogen here, that is 2 plus 1. We have 3 hydrogen on the reactant side. On the product side, we have what? 2 hydrogen. So here we have 3 hydrogen, which is odd number, and here we have an even number 2. So we have to what? Make this odd number to become even number by what? Putting 2 here, so that 2 times 1 will be 2. Then plus this 2. 2 of hydrogen plus 2 of hydrogen. We are using this to multiply this because it looks like factorization in mathematics where this case means that 2 is affecting both A and B. So whatever number in front of this compound is affecting everything, including sodium, oxygen, and what? Hydrogen. Okay, so hydrogen is now balanced. So let us look at, hydrogen is what? 2 here plus 2 here, which is what? 4, right? So to make this one to balance, we put 2 here, meaning that hydrogen is 4 now. Okay, so it is balanced at this point. Then sulfur is what? 1 here on the reactant side, and also 1 on the product side. So sulfur is now balanced. Okay, oxygen is how many? Oxygen is what? 4 plus, there is oxygen here, therefore it is 2, right? So 4 plus 2 is what? 6. On the product side, oxygen is what? 4 plus, this 2 is also affecting oxygen, therefore it's 4 plus 2, also 6. Therefore oxygen is what? Balanced. Sodium is what? 2. Sodium is 2 here. So all of them are what? Balanced. So now we can now bring out what our Na is, what Na is, and what Nb is. Na is what? 1. There is an invisible 1 here. If there is no number here, it means that there is invisible 1. Okay, so Na, which is the number of mole of acid, is what? 1. Nb is what? 2, because 2 is standing in front of this base. Okay, so this is it. Let us give another example where we will find out how to balance chemical equation, also involving neutralization what? Reaction. Please note that this is also applied to all types of reaction. The same way we balance this chemical equation is the same way we balance other types of what? Chemical equations or reactions. Okay, let's see what will happen between, let's say, nitric acid and, let's say, calcium hydroxide. Okay, this will give you what? Calcium nitrate and what? Water. Okay, so hydrogen is 1 here, hydrogen is 1 here, plus there is 2 hydrogen here, therefore it's total of 3 on the reactant side. Hydrogen is what? 2 on the product side. So we have to balance this one that is an odd number by putting 2 here, right? So hydrogen is how many now? 2 plus hydrogen is 2 here. 2 plus 2 is what? Total of 4 on the reactant side. On the product side, hydrogen is what? 2. So to make it 4, you put 2 here, right? So we'll go over to nitrogen. Nitrogen is what? 2 here, right? Nitrogen is what? 2 here, because this 2 is also affecting the nitrogen. Then we go over to oxygen. Oxygen is 2 times 3, that is 6 for this compound, plus oxygen is 2 in this compound. So 2 plus 6 is total of what? 8, right? Then oxygen is how many here? 6. 6 plus 2 is also what? 8, right? So oxygen is balanced. Then calcium is 1. Calcium is 1. See that all of them are all balanced. Okay, so Na in this case is what? 2, because 2 is standing as what? Number of mole of this acid, Na. Okay, Nb is equal to invisible what? 1. You can see you cannot just be guessing Na and Nb, because in this particular case Na is 1, NB is 2. Then this gave an alternate answer, like an opposite answer. NA is 2, where NB is what? 1. So there are other cases where you can get NA to be 1 and NB to be 1. You see that you cannot just be guessing this. Let's see what will happen between hydrochloric acid and what? Potassium hydroxide. This will be what? Potassium chloride plus what? Water. Okay, hydrogen is 1 plus another 1 here, that is total of 2. On the product side, hydrogen is what? 2. Chlorine is 1 here. On the product side, chlorine is what? 1. Then potassium is 1 here. Potassium is 1 on the product side. Oxygen is 1. Oxygen is 1. So it is what? Balanced. So Na is equal to what? How many? 1. Then Nb is equal to how many here? 1. You can see you cannot just be guessing Na and Nb while what? Trying to apply what? Dilution what? Formula. Okay, this is just the first formula we'll be using in solving questions involving quantitative analysis. So let us go over to the second formula. Okay, to the second formula. The second formula is formula for molar concentration, or what we call what? Molarity. Okay, formula says it is mass over what? Molar mass. Molar mass. Molar mass can also be called relative molecular mass. Then times what? 1000 over what? Volume. This 1000 is just to convert the volume that is what? In what? cm cube to what? gm cube, so that at the end of the day, the unit of molarity or molar concentration will be in what? In what? Mole per what? dm cube. Mole per what? dm cube. This is the unit of what? Molar concentration. You will find out that it is in dm cube. So this 1000 over volume is just a way of what? Converting this cm cube that we use in practice or while conducting titration, because all our apparatus are in cm cube. Okay, the pipette and the burette are in cm cube. So 1000 here is for conversion. All right, so let us see possible parameters that can come out from this formula. So this is mass over molar mass. This and this alone is formula for number of mole, which is what? Mass over what? Molar mass, which is the same thing as relative molecular mass. There is a slight difference. I will tell you what it is. Okay, so we can just substitute N for this particular word, mass over molar mass. In which case, let us rewrite this. So mass concentration, molar concentration will be equal to what? Number of mole. You can see that this, we are using it to substitute this, because this is the formula for this. Okay, so number of mole times what? 1000 over what? Volume. This is also a possible formula that you can also what? Apply in solving this quantitative analysis. So we can still, bring out some other possible formulas. For instance, the formula for what? Mass concentration. Remember I told you that molar concentration is in mole per dm cube. There is another form or type of concentration that is in gram per dm cube. So let us just discuss what concentration is. Concentration is the amount of solute in 1 dm cube of the solution. Right? The amount of what? Solute in 1 dm cube of what? The solution. So if it is in terms of mole, it is the number of mole of what? a solute in 1 dm cube of the solution. That will give you what? Molar concentration. Therefore, we can say that there are two types of what? Concentration. The first one is what? Molar concentration, which we also call what? Molarity. The other type is what? Mass concentration. Is what? Mass concentration. The unit of molar concentration is what? Mole per dm cube, or capital M. Sometimes you will be seeing capital what? M. But the unit of mass concentration is what? Gram per what? Dm cube. This is the mass of the solute in 1 dm cube of the solution. This is the what? The mass of the solute in 1 dm cube of the solution. Why this is what? The number of mole of the solute in 1 dm cube of the what? Solution. Okay, let us see if there is a way to what? Bring the two of them together in one single formula. What could that be? That would be what? Molar concentration to be equal to what? Mass concentration over what? Molar mass. How did we come about this formula? Mass concentration is in gram per what? Dm cube. It means that it is the mass. Let me clean this thing. It is the mass over what? Volume. G is for mass. You can see that the D is in what? Volume. So we have mass over volume inside this mass concentration. Then this molar mass remain where it is. Okay? So this is another what? Possible what? Formula we will be what? Adopting in solving what? Questions involving quantitative analysis. Okay? Now the question is, this molar mass we have been calling relative molecular mass. What is the difference between them? Are they different? No, they are not different. The relative molecular mass is just describing the fact that carbon-12 isotope was used to measure all the atoms of elements that are existing. Okay, that is why we call it relative molecular mass. It is now the sum of individual relative atomic masses of the elements that make up a particular compound. Okay, where the molar mass is just used to describe the relative molecular mass of a compound in a solution. Therefore, the unit of relative molecular mass is just in gram, while the unit of molar mass is this same mass in mole. So we call it gram per mole. Molar mass, gram per mole. Then only relative molecular mass as just mass is just gram. So questions could come this way: what is the molar mass of, or what is the mass in 1 mole of? Okay, they are still talking about molar mass, which is the same thing in theory as what? Relative molecular mass. How do we get relative molecular mass? We get it by what? Adding individual relative atomic masses of the elements that make up a compound. For instance, let's say CO2 now. That we should find the what? Relative molecular mass of CO2. How do we go about it? The relative atomic mass of carbon is what? 12. I'll tell you how we get relative atomic mass. Okay, it's 12 plus, then relative atomic mass of oxygen is what? 16, but oxygen carries 2, so 2 will multiply that 16. Okay, so we have what? 12 plus what? 32. So that would be what? 44. Since we are talking about relative molecular mass, the unit is going to be in gram. If the question was to find the molar mass of CO2, then it will be in gram per mole. Is that okay? So let us see what relative atomic mass is shortly. This is what 2 times atomic number. We get it by what? Multiplying the atomic number of that element by 2. This does not apply for all the elements because there are some exceptions. Okay, let's use this formula to see examples of elements that follow this formula. Let's see elements like carbon. Carbon is what? Atomic number 6. So 2 times 6 will give you what? 12. This is the what? Relative atomic mass of what? Carbon. Let's see nitrogen, which is 7. 2 times 7 is what? 14. It means that 14 is the relative atomic mass of what? Nitrogen. Let's see oxygen, atomic number 8. 2 times what? 8. That is 16. It means that 16 is the relative atomic mass of what? Oxygen, and so on and so forth. However, there are exceptions. The few exceptions are hydrogen is number 1, having relative atomic mass as what? 1. You can see that if it was to follow this formula, it would be 2 times 1, which is what? 2. But the relative atomic mass is 1, meaning that it is an exception. Another exception is what? Sodium. Sodium has atomic number 11. So if it was to follow this formula, it would be 2 times 11, 22. But the relative atomic mass of sodium is what? 23. Another exception is what? Chlorine. Chlorine is 17. If it was to follow this formula, it would be 34, right? But the relative atomic mass of chlorine is what? 35.5. Then another exception is what? Potassium. Potassium is atomic number 19. If it was to follow this, it will give you 38, but the relative atomic mass is what? 39. One other one that is not among the first 20 elements, but is usually we usually apply it, or we usually find it in our question, is what? Copper. Copper is what? 63.5. If it was to follow this formula, it would be 64, but it gave us 63.5. So you cannot just tell me that it is the same thing by approximation. It is not the same thing. You have to respect this particular value and indicate that decimal point. The reason why this and this produced decimal point is because they are what? Isotopic mixtures. They are what? Isotopic mixtures. Chlorine has isotopes. So when you add their isotopes and divide it by the average, you get an average number with a decimal point. The same thing will happen to copper. Copper has isotopes. So the reason why they form decimal points in their relative atomic mass is because they have isotopic mixtures. Okay, so that is that. This is a typical JAMB question. Okay, so if we are solving questions involving relative molecular mass or molar mass, you will need this particular word hint that I just brought out in order to what? Solve it, even without them enlisting it in the question. Okay, so the next formula that is important in solving quantitative analysis is what? The one involving particles. Particles. Particles are elementary entities. Are what? Elementary entities. So they could be number of atoms, could be number of molecules, not number of mole. Mole is different from molecules. It could be number of ions, it could be number of electrons. You can notice that these are particles, right? Atom, molecule, ions, electrons. protons, number of anything that is not number of mole, all other things, number of whatever, fall under what? Particles. Okay, so we'll be classifying all of them as what? Particles. The formula is what? Particle equal to what? Mole times Avogadro's number, which we have as 6.02 times 10 raised to power what? 23. This is called Avogadro's number or Avogadro's constant. Okay, so you need to take note of this. In situations where you need to find what number of mole is, remember that number of mole is equal to what? Mass over what? Molar mass, right? Then you now need to put this one to complete the formula. Alright, you need to memorize this figure. Alright, these are the different formulas that we apply in solving questions involving quantitative analysis. The next one I'm going to give you is a question that will bring in everything. But before that, let us know how to manipulate, forge, or create table of value after conducting titration. Okay, this is very important in Nigeria examination because we know how the system works. If you are not smart, I don't know how you will cope in your exam. Okay, so you need to listen carefully to know how you can create your own table, because you may not be given the opportunity for every student in the hall to conduct titration during your exam. So the teacher will normally have an endpoint that he or she had submitted to WAEC. So if you are in the know of that particular endpoint, you need to understand this table to know how to maneuver things and scale through in your exam. Okay, please pay attention. The table is in this format. You need to write your burette reading first, and please specify the unit, which is in what? cm cube. Okay, then you have your first titer also in cm cube. Everything should be in cm cube. Your second titer in what? cm cube. Your third titer in what? cm cube. You will have to stop in what? In third titer. Okay, please make sure you don't use only 2 titers. The least is 3 titers. You can do 4, 5 and above, but the best is what? To use 3 titer values. So the next thing to do is what? To put your final reading. Your final reading followed by your what? Initial reading, and then lastly what? The volume of acid used. Volume of what? Acid used. All right, this okay, please, while filling in whatever you are going to fill inside these spaces, make sure that your decimal point is in 2 decimal places. You must put it in 2 decimal places. Okay, in chemistry we use 2 decimal places in this table. Then for the final answers, it could be in 2 decimal places or in 4 decimal places. It can only be in 4 decimal places if the number has long decimal, like there are many numbers after the decimal point. But if there are just few numbers, like almost a whole number but 1 decimal place, make sure that you complete it to 2 decimal places. Okay, so the initial will always be 0.00. Other ones you can manipulate it. Now for us, please pay attention. You have to deal with this volume of acid used so that you will be able to know how to fix in different values here on your own without even conducting the titration yourself. This is not the best practice, the best way to do it. But we do it like this because of the Nigeria factor. Okay, so please pay attention very well. If your teacher submitted, for instance, 18.00 cm cube to WAEC as his or her endpoint, you must work with this value, but it is not necessarily compulsory for you to get this value, because WAEC knows that there are limits of experimental errors. So, but we work within this limit of experimental error, which is plus or minus 0.2. In other words, if your answer must be more than this, it should not be more than this by above 0.2. So the proper answer to get should be either 18.10 cm cube or 18.20 cm cube at max. It must not be above this. So this is the plus aspect, that is if you want to be above. Then if you want to go below this 18, if your result must be below this 18, please pay attention. You must not go below the 18 more than 0.2. So let us see what could be the answer here. You have 17.90 cm cube or 17.80 cm cube. These are the 5 answers that you can get and you'll be correct. So you can get exactly what the teacher got, you can get this or the other ones. Okay, so but your table must be different. Let's say you want to get exactly 18.00. You did not see what your teacher solved or titrated and gave to the WAEC, okay? But you can get the same answer, knowing that if you create 3 values, let the first one be 18.00. Then the next one, if the next one is 18.20, the other one that is remaining, you have to remove this 18.20 from 18. That would be 17.80. So you can see that if you add this 0.2 on this, it will be 18. Therefore everything will be 18, right? So when you divide it by 3, you automatically have 18.00 cm cube, exactly what your teacher got, but with different results. Then if you decide to make it this way, that you don't want to put this, you can have 18.00 plus, let's say you added 1, it will be 18.10. Then the next one, you remove 0.1, this 0.1 that you added on this 18, you remove it from this 18. That will give you 17.90. So you see that if you bring this 0.1 you added here and add it here, all of them will be 18.0. So when you divide by 3, you still have 18.00. So you see that one person could have this type of result, the other person will have this type of result. Then this is how you keep on changing the results, doing remove and add. You do the logic before you come into this place. So let's say we choose any of these. Let's choose this, for instance. This could be our 18.00, right? So you can put 18.10 here, then 17.90. The other person beside you can alternate this and these values. One could put here, then this one here, then this one this side. You know how to arrange it so that everybody will have different values. Then this is also important to know that you must have different results here. The point is that you are getting similar answers, but your tables must be different so that it wouldn't look like you did exam malpractice. Okay, now this plus this will give us this, which is 18.10. The normal way to do it is final minus initial. 18.10 minus 0.00 should give you this. But because we are manipulating our table, we are using our hand to forge or create our own table, right? We can do this plus this to give us this. It is the same thing. So you can put any other values here. If I decide to put 6.50 here, this plus this will become what? will become what? 24.50. When you do this minus this, you have this, right? The other person will decide to put, let's say, 10.60, right? This will give you what? Which is what? 5, right? 8 and 2. So 28.50, right? Another person can do any other thing. You can change values. You know the way you want your table to appear. So you can change values here, and everything will keep on changing. Meanwhile, you know where you are heading to because you have solved it somewhere. Okay? And you have gotten your what? Answer. So the value is what? The average volume of acid. The average volume of what? Acid used. Average is what? This plus this plus this. 18.10 plus what? 18.00 plus 17.90 all over what? 3, because they are 3 titers, right? Will give you what? 18.00 what? cm cube. See, we are putting it in 2 decimal places because there are no long decimal numbers. Okay? So what if your teacher submitted, let's say your teacher submitted 22.30 cm cube. 22.30 cm cube is what your teacher submitted. The correct answers you must get in order to be correct should be, above this should be 22.40 cm cube or 22.50 cm cube. Then if you want to go below what your teacher got, if you don't want to get exactly the same thing, it will be what? 22.20 cm cube or 22.10 cm cube. These are the 5 possible answers you will get to be correct. Is that okay? So let us choose one. Let's say we want to get 22.50 cm cube. Okay? So let's wipe this. Your first title must have initial of 0.00, okay, because it shows that you filled the burette while conducting your titration. Okay, so we want to get 22.50 cm cube. Just do the logic somewhere, 10.10. Then the next one, you remove 0.1. This 0.1 that you added on this 18, you remove it from this 18. That will give you what? 17.90. So you see that if you bring this 0.1 you added here and add it here, all of them will be what? 18.0. So when you divide by 3, you still have what? 18.00. So you see that one person could have this type of result, the other person will have this type of result. Then this is how you keep on changing the what? Results, doing remove and add. You do the logic before you what? Come into this place. So let's say we choose any of these. Let's choose this, for instance. This could be our 18.00, right? So you can put 18.10 here, then 17.90. The other person beside you can alternate this and these values. One could put here, then this one here, then this one this side. You know how to arrange it so that everybody will have different values. Then this is also important to know that you must have different results here. The point is that you are getting similar answers, but your tables must be different so that it wouldn't look like you did exam malpractice. Okay, now this plus this will give us this, which is what? 18.10. The normal way to do it is final minus initial. 18.10 minus 0.00 should give you this. But because we are manipulating our table, we are using our hand to forge or create our own table, right? We can do this plus this to give us this. It is the same thing. So you can put any other values here. If I decide to put 6.50 here, this plus this will become what? Will become what? 20 what? 3. 24.50. When you do this minus this, you have this, right? The other person will decide to put, let's say, 10.60, right? This will give you what? Which is what? 5, right? 8 and 2. So 28.50, right? Another person can do any other thing. You can change values. You know the way you want your table to appear. So you can change values here, and everything will keep on changing. Meanwhile, you know where you are heading to because you have solved it somewhere. Okay? And you have gotten your what? Answer. So the value is what? The average volume of acid. The average volume of what? Acid used. Average is what? This plus this plus this. 18.10 plus what? 18.00 plus 17.90. All over what? 3, because they are 3 titles, right? Will give you what? 18.00 what? cm cube. See, we are putting it in 2 decimal places because there are no long decimal numbers. Okay? So what if your teacher submitted, let's say your teacher submitted 22.30 cm cube. 22.30 cm cube is what your teacher submitted. The correct answers you must get in order to be correct should be, above this should be 22.40 cm cube or 22.50 cm cube. Then if you want to go below what your teacher got, if you don't want to get exactly the same thing, it will be what? 22.20 cm cube or 22.10 cm cube. These are the 5 possible answers you will get to be correct. Is that okay? So let us choose one. Let's say we want to get 22.50 cm cube. Okay? So let's wipe this. Your first title must have initial of 0.00, okay, because it shows that you filled the burette while conducting your titration. Okay, so we want to get 22.50 cm cube. Just do the logic somewhere in a rough sheet. We want to get 22.50, so let's say 22.50 will be here. Then let the first one, let's remove 2, then we can add it back. That should be 22.30. Then let us add back that 2 on this. That will be what? 22.70. You see that if you bring this 0.2 you added here to get 22.7, if you bring that 0.2 and add it here, all of them will be 22.50. You see that when you divide by 3, you still get this, right? So let us fix in these values in the table. We have what? 22.30. Here is 22.50. Here is what? 22.70. So this plus this will give you what? 22.30. Right? So we can put any number here. Right? We can put, let's say we put 13.00. When you add this, you have what? 35.50. So this could be, let's say you put like 3.50. When you add it to this, you have what? 0. This will give you 0. That is what? That is 12. 2 point. This is what? 4. Then put it here. That will be what? 6. 26 point what? So the average volume of acid used, is this plus this plus this over 3. So we have 22.30 plus 22.50 plus what? 22.70 all over what? 3. Right? So this is it. If you do not see a question that says find the average volume of acid used, they could say find the average titer. Average titer. It is still the same thing as what? The average volume of acid used, which I tell you that this thing is also the same thing as your VA, right? Volume of acid used. It is what we call the endpoint, which is what? At this point, when you divide it, you have 22.50 cm cube. So let us use this particular table now to form questions which will enable us to what? Apply these formulas I had earlier provided us. Okay, there are 3 formulas I gave us. I gave us for dilution formula, for molar concentration, or what we call the molarity, and finally for particles. Okay, let's say with that same table, they now say that the table is for a titration of what? Let's say 25 cm cube capacity pipette. That is, it means that this is the volume of the base of what? 0.02, for instance, mole per dm cube of what? Potassium hydroxide, which is what? The titration between potassium hydroxide against what? Against let's say HCl, against HCl, which is the acid. Okay, then they said calculate A. Let's say the question is to find the concentration of the acid in mole per dm cube. Then the second question, calculate the concentration of what? The acid in gram per dm cube. This is just to test your ability to differentiate between molar concentration and mass concentration. Then finally, let's say the question is to find the mass of what? The base, potassium hydroxide, required to prepare what? 250 what? cm cube of the solution. Right? So these questions are just questions that will test how we understand these different formulas I have given you. Okay, the first one, let us treat the first one. The concentration of the acid in mole per dm cube, we can use what? The dilution formula to obtain it. Okay, where Ca is what we are looking for, concentration of the acid Ca, then Cb is given to us as what? 0.02 mole per what? dm cube. Cb, this is the base, right? So the Va is what we obtained from the titration, the table, which we got the end point as what? 22.50 cm cube, right? Then Vb is the volume of our pipette, which is indicated as what? 25 what? cm cube, right? Then the Na we don't know it yet. NB, we don't know it yet. How do we know Na and NB? By what? Balancing the chemical equation between what? This and this, potassium hydroxide and HCl. So this is a neutralization reaction. HCl plus what? Potassium hydroxide will give you potassium chloride and water. We have done this before and we found out that Na is equal to 1. Let's just do it here. Hydrogen is 1 here, hydrogen is 1, which is total of 2 in the reactant side. In the product side, hydrogen is what? 2. So hydrogen is balanced. Chlorine is 1 here in the reactant side. Chlorine is what? 1 in the product side. So it is balanced. Potassium is 1 here. Potassium is 1 in the other side. Oxygen is 1. Oxygen is 1. So this is a balanced chemical equation. So the number of mole of acid is what? 1 here. Is 1. The number of mole of base is also what? 1. So let us apply this in the formula, where Ca is what we are looking for times Va is the average volume of acid used, which is the end point, 22.50, all over Cb is what? Given as 0.02 times Vb is the volume of what? The pipette, then equal to 1 over what? 1. Therefore, the Ca is equal to 0.02 times 25 all over what? 22.5. So Ca is equal to, when you multiply 0.02 by the 25, it should give you 0.5. It should give you 0.5. Then 0.5 over what? 22.50 should give you 0.02222222 etc. That's a recurring decimal. Please note that in quantitative analysis, when you have long decimal points, your answer should be in 4 decimal places. This is the 4th decimal place. Okay, so that is our answer. This should be mole per dm cube, in mole per dm cube. Okay, so we've gotten our answer in mole per dm cube. The next question is to solve the concentration of the acid in gram per dm cube. How do you solve the concentration in gram per dm cube? The formula is molar concentration is equal to what? Mass concentration over what? Molar mass, right? So the molar concentration of the acid that we have gotten from that final answer we just solved is what? 0.0222 equal to the mass concentration we are looking for over what? The molar mass of the acid. The molar mass of HCl is what? What is the relative atomic mass of hydrogen? 1. Plus, what is the relative atomic mass of chlorine? 35.5. So the relative molecular mass is what? 36.5 gram. This is what we are going to write here. So do cross some multiply. You have what? That your mass concentration is equal to this times this should give you, let's say, 0.8111. This is the 4th decimal place, gram per what? dm cube. This is your concentration in gram per dm cube. Then the last question says we should find what? The mass of potassium hydroxide required to prepare 250 cm³ of what? The potassium hydroxide solution, right? So the molar concentration of this potassium hydroxide is 0.02. We are going to look for a formula that will bring in both molar concentration of the base, the mass, then and the volume, which is also the general formula for molar concentration, or what we call molarity. That will give us what? Molarity or molar concentration is equal to mass over what? Molar mass times 1000 over what? Volume, right? So what is the molar concentration of potassium hydroxide? From the question we have it as what? 0.02 equal to, this is the mass we are looking for, over what is the molar mass of what? Potassium hydroxide. This is what? The relative atomic mass of potassium is what? 39. For oxygen is what? 16, and then hydrogen is 1. This is 40 plus 16, that is what? 56 gram, right? So we'll be writing 56 here times what? 1000 over what? 250 what? cm³. This in this is 4. This in this is 14. Like 4 in 56 is what? 14, right? So when you multiply 14 with this, 40, there's mass equal to 0.02 times 14 should give you 28 over 100. That is what? 0.28. This is in gram. Okay, we have been able to solve this. Is that okay? So these are the formulas we use in solving what? Questions involving quantitative analysis. Then the next question we are going to ask here is, how do we apply the formula for particles? Okay, let me ask a question that will what? Help us to apply formula for particle. Let's say we are asked a question like, calculate the, let's say, the mass of let's say sodium sulfate, sodium sulfate calculate the mass of sodium sulfate required to prepare, let's say required to prepare let's see 500 cm³ of, let's say, 0.5 mole of the solution. Okay, with this kind of question, you can see molarity, you can see volume, you know we can find mass, because there is a formula that unites mass, molar mass, volume, and what? Molarity. That is the formula we are going to use here. Okay, which is what? Molar concentration is what? Mass over what? Molar mass times 1000 over what? The volume, where we have 0.5 is equal to what? What is the mass of what is the mass of, okay, the mass is what we are looking for, over what is the relative molecular mass of sodium sulfate. Sodium is 23, but it has to, so 2 will multiply that 23, right? So plus the relative atomic mass of sulfur is what? 32, plus relative atomic mass of oxygen is 16, but oxygen has 4, so we have 4 times what? That's 16. This is 46 plus 32 plus 64. This is 110. So this is 142 gram. 142 times what? 1000 over what? Let's say 500. This over this is what? 2, right? 2 itself 1. 2 here is 70 what? 1. Half of 71 means that the mass is what? 0.5 times 71. Half of 71 is what? 35.5 what? Gram, right? So with this, the second part of the question can come as B. Calculate the number of what? Sodium sulfate what? Molecules. Sodium sulfate what? Molecules. So to find this, since the question is about particle, we have to use particle equals to mole times Avogadro's constant, right? Let me use this space. Calculate the number of sodium sulfate molecule. The question is from particle. Particle is equal to what? Mole times Avogadro's constant, which is equal to 6.02 times 10 raised to the power 23, right? So P is equal to number of mole is the same thing as mass over what? Molar mass. Then you put your times 6.02 times 10 raised to the power 23. So P is what we are looking for because they said the number of molecule. Remember that number of molecule is also classified as particle, right? So the mass that we obtained from the last calculation was what? 35.5 gram. All over the number of the relative molecular mass of this, we got it as 142. Then times this 6.02 times 10 raised to the power 23. When you do this, it should give you something like 0.25 times this. Your final answer should be 1.505 times 10 raised to the power 23, which is what? Molecules of what? Sodium sulfate. So this is how to apply particle, the formula for particle in solving questions in quantitative analysis. I hope you understand this. Please take your time to watch and rewatch this video properly so that you will digest everything that we have said here.